Hello everyone, welcome back to my YouTube channel. I, Mr. Yogesh, Faculty of Mathematics, and I am here to put excitement back into the education. In this lecture, we are going to discuss question number 4 and 5 from first chapter, Similarity. Questions are from question bank provided by Maharashtra State Board. Look at the first question. We have it is of the form. Side of a equilateral triangle PQR is 8 cm. Then find the area of triangle whose side is half of the side of triangle PQR. So once here we have given triangle PQR is an equilateral triangle, so that we have the formula for finding the area of a equilateral triangle. It is of the form, we are writing area of triangle PQR, that to be equals to we have root 3 by 4 times side square. Now we have length of the side is 8 cm, so that we are getting root 3 by 4 into we have now 8 square. So 8 square is 64. So root 3 by 4 times we have a 64. We well known 4 ones are 4, 16 fours are we have a 64. So that we are getting here area of triangle PQR, that to be equals to now 16 times root 3, that much a square of centimeter. Now we have to find that area of a other triangle whose side is half of side of triangle PQR. So let us assume that we have the other triangle, triangle ABC, in which we have side of a triangle which is half of side of a triangle PQR. We have, let us consider the first side becomes the PQ. Now we have to evaluate the area of triangle ABC. So that to be equals to now we have root 3 by 4 times we have half of the side as compared to the side of triangle PQR, so that I am writing here side divided by 2 the whole square. That means once we separate out the square, we are getting root 3 by 4 into we have a side square divided by 2 square is 4. Now once we are writing the formula, it is of the form, we are taking 1 by 4 outside, 1 by 4 times we have root 3 by 4 into we have the side square, and the value for area of triangle PQR is nothing but root 3 by 4 times we have a side square, and whose value we have a 16 times root 3. So let's try to replace now area of triangle PQR by its value. We are having 16 times root of 3, so that we are getting here required area of triangle ABC, that to be equals to 1 by 4 into 16 times root 3. Now we well known 4 ones are 4, 4 fours are 16. So that area of triangle ABC, that to be equals to we have 4 times root of 3, that much square of centimeter. So that we are writing therefore area of required triangle, area of required triangle, we have it is of the form 4 times root of 3 centimeter square. Now look at the question number 2. Area of two similar triangles are equal, then prove that triangles are congruent. That means at start we have given there are, let it be, we are considering the two triangles ABC and triangle PQR. Those two triangles are similar. We have area of two similar triangles are equal. That means we are writing area of triangle ABC is equal to we have a area of triangle PQR. Now once we consider here the theorem, I am writing by ratio of area of two similar triangle theorem. We are having ratio of area of two similar triangle, that means area of triangle ABC divided by area of triangle PQR, that is equals to we have ratio of squares of their corresponding sides. That means we can write here AB square divided by PQ square, or might be BC square divided by QR square, or maybe AC square divided by PR square. Now once we consider first two ratios are equal, that means area of triangle ABC is divided by area of triangle PQR is equal to AB square divided by PQ square, and once the given two triangles having the same area, we may call this as a equation number 1. Now we are writing from equation 1, area of triangle ABC is same as that of area of triangle PQR, so that we are getting area of triangle PQR divided by area of triangle PQR, that to be equals to AB square divided by PQ square. Now once the numerator denominator is same getting cancelled, so that should implies now we have AB square divided by PQ square is equal to 1 upon 1 means we have a 1. So once we shift now the PQ square from left to right direction, we are getting AB square is equal to PQ square. Once we are taking now the square root on both sides, so that we are having AB is equal to PQ. Similarly, once we consider the area ratio becomes equals to the BC square divided by QR square, or area ratio becomes equals to the AC square divided by PR square, so that we are getting similarly BC equals to we have the QR and AC is equals to we have the PR. So once the three sides of one triangle are equals to the corresponding three sides of the other triangle, that means we can write now in triangle ABC and a triangle PQR. What we have? Segment AB is equal to PQ means once the given two segments are having the same length means they are congruent. Segment AB is congruent to segment, we are writing PQ. Let's call this both equation as a equation number 2. Next to each segment we have the BC is congruent to now once they are having the same length, BC equals to QR we have, so we can write they are congruent to that of segment QR, and at the last segment AC which is congruent to that of segment PR from equation 2. Once the three sides of a one triangle are congruent to corresponding three sides of the other triangle, then we can say that given two triangle, that means triangle ABC and triangle PQR are congruent by using here side test. Hence once the two similar triangle having the same area, then we can say that given two triangles are congruent. Now look at the question number 3. Two triangles are similar. Smaller triangle sides are 4 cm, 5 cm, 6 cm. Perimeter of larger triangle is 90 cm. Then find the sides of larger triangle. So let us try to consider the two triangle. We have supposed to be the first triangle is the triangle ABC, which is a smaller triangle, and other triangle we have let it be the triangle PQR. Now we have given the length of AB is equals to, let us consider 4 cm, length of BC 5 cm, and length of AC is 6 cm. And let us we are assuming now the length of PQ is X cm, length of QR is Y cm, and length of PR is Z cm. So now as per the given, we have triangle ABC is similar to triangle we have PQR, and perimeter of larger triangle we have given 90 cm. Now what is mean by the perimeter of a triangle? Sum of all sides of a triangle. So that we have X plus Y plus Z, that is equals to a 90. Now once here triangle ABC is similar to triangle PQR, once the triangles are similar, then their corresponding sides are in equal proportion. That means we can able to write now AB divided by PQ, that to be equals to BC divided by QR, that to be equals to we have a AC divided by PR. What will becomes, we can write the reason behind it. corresponding sides of similar triangle. Now let's try to replace by their value. We are having here value of AB which is 4, PQ is X, value of BC is 5, QR is Y, AC is 6 and PR is we have a Z. Now here once we consider the first two ratios are equal, 4 divided by X that is equals to, we have let it be a 5 divided by Y. So that we are getting by using the cross ratio test 4y that to be equals to 5x. Try to rearrange the equation in terms of general form of linear equation in two variable. We are getting 4x minus 5x minus 4y that to be equals to 0, called it as the equation number 1. Now once we equate either first and the last ratio or second and the last ratio, we are considering first and the last ratio. 4 by x to be equals to, we have a 6 by z. Now 2 2s are 4 and 2 3s are 6, so we can write it is of the form 2 by x to be equals to, we have a 3 by z. Now as per the given, we have x plus y plus z that is equals to 90, so that we can evaluate here value of z. After all shifting x and y from LHS to RHS, we are getting 90 minus x minus y. So that we have now 2 divided by x that is equals to, try to replace now z by its value, we have a 90 minus x minus of y. Use the cross ratio test so that we are getting 2 times 90 minus x minus y that to be equals to, we have 3 times x. Try to distribute now this 2 to over bracket, we are getting 90 to the 180, x into 2 we have a 2, x plus minus becomes minus of 2x, again plus minus minus 2 into y we have minus of 2y now, and that is equals to 3x. Try to shift minus of 2x minus of 2y from LHS to RHS, so that the general form of linear equation in two variable, we are getting it is of the form 3x plus 2y plus 2x that to be equals to, we have 180. Now 3x plus 2x we have 5x plus 2y that is equals to 180, called it as equation number 2. Look at the equation 1 and 2 carefully. Once we multiply equation 2 by 2, we are getting 5 2s are 10x plus 2 2s are, we have a 4 times y as it is, that is equals to 180 2s are, we have a 360. Call that new equation as a equation number 3. Now once we add up the equation 1 and 3, so that we eliminated y variable over there. So let us try to add up equation 1 and equation 3. We are getting 10x plus 5x becomes 15x, that to be equals to, now minus 4y plus 4y getting cancel or gives us a 0. 360 plus 0 we have 360. Now once we shift 15 from LHS to RHS, so the value of x we are getting 360 divided by 15, we have 15 2s are 30, remainder is 6, generate 60, 15 4s are, we have a 60, so that value of x is 24. Now to evaluate the value of y, already we have the equation of the kind 4y to be equals to a 5x. We are writing we have. As per the equation 1 we might be says. Now to evaluate the value of y, shift that 4, we are getting 5 by 4 into x. Now try to replace x by its value, we have a 24. So the value of y we have 5 by 4 times 24. Now 4 1s are 4, 4 6 are, we have a 24. So that should implies the value of y becomes 5 into 6. 6 5s are, we have a 30. So that we are getting the value of y is 30. Now to evaluate the z, already we have the value of z becomes 90 minus x minus y. So that we are getting 90 minus of 24 and minus of y value we have a 30. So that we have now 90 minus of minus 24 minus 30, we are having minus of 54. 90 minus 54 becomes 36. So that the value of z we are getting a 36. So at last we are writing the length of the sides of larger triangle, we have length of sides of larger triangle, that we assume that as a triangle PQR. We have x is 24, unit is centimeter, y is 30, unit is centimeter, and the third side we have a 36 centimeter here. So hence here we have all sub questions from question number 4. Now look at the question number 5. First sub question we have, it is of the form, in figure PS is equals to 2. We have given the value of PS. Here we have the S point. PS is 2. Next to it, SQ is 6. So that we have SQ to be equals to 6. Next to it, QR equals to 5. So I am writing QR, that is 5. Next to it, we have PT equals to X. So we are having PT value is X. And next TR to be equals to Y. So that we have TR equals to Y. Then find the pair of values of X and Y such that ST is parallel to QR. Once we consider if here ST is parallel to the side QR, then by basic proportionality theorem, we are writing by basic proportionality theorem, we may have here PS divided by SQ, that to be equals to PT divided by TR. Try to replace by their value. We have PS is 2, SQ is 6, while PT is X, TR is Y. Now we well known 2 1s are 2, 2 3s are 6, so that we are getting X by Y to be equals to 1 by 3. Now once we use the cross ratio test, means we are shifting Y from LHS to RHS and 3 from RHS to LHS, so that we are getting 3x to be equals to Y. That is, we are writing Y to be equals to here 3x. So now we are having, I am writing here, we have pairs of values of X and Y are of the form. If we consider the value of X is 1, that should implies Y is equal to 3. So X comma Y we are having now the 1 comma 3. And once if we consider the value of X is 2, you may take any one integer value over here or any one real number, so that we are getting the corresponding value of Y is of the form. Once X is 2, so 3 2s are we have a 6. So next pair of value X comma Y is to be equals to, we have value of X is 2, Y is 6. So that we are writing, we have pair of values of X and Y such that segment ST parallel to side we have a QR are of the form 1 comma 3 and we have a 2 comma 6. Look at the second question from question number 5. An architecture have model building. Length of the building is 1 meter. Then the length of model is 0.75 centimeter. Then find the length and the height of the model building whose actual length is 22.5 meter and height is 10 meter. So that here we have given the scale is of the form 1 meter to be equals to, we have 0.75 centimeter. So that should implies now length of model to be equals to, once we multiply both side by, we have given 22.5. So once we multiply both side by 22.5, so that 22.5 meter, that to be equals to, now we have 22.5 into 0.75. So the length of the model we are getting 22.5 into 0.75. Forget about at start the decimal, we have the number that is 225 and 75. Try to multiply them. 225 into 75, we are getting 16,875. Now let us try to put the decimal. We have after 1 place and after 2 place, so that 1 plus 2 becomes, after 3 places we have to put the decimal, so that we are getting length of model that to be equals to 16.875 that much centimeter now. So that I am writing length of model to be equals to, we have 16.875. Now look at after we have given the height of model, that is 10 meter. So that height of model we have now the 10 meter. Once 1 meter to be equals to 0.75, try to multiply both side by 10, so that we are getting 10 meter to be equals to, now 10 into 0.75, we have 7.5 centimeter. So that we are writing at last the height of model to be equals to, we have 7.5 centimeter. Hence here now we have all 5 questions from the first chapter, similarity. Thank you.